Today we will study differentiation of hyperbolic function. What is hyperbolic function? Hyperbolic function defined by Sinh with an x will be equal e to the x minus e to the minus x divided by 2, and cos of x will be equal e to the x plus e minus x divided by 2, and tangent with an x, remember I'm going to have an x here, equal e. If you take this, you take sin x divided by u, it will be equal ax minus e to minus x divided by 2, the whole thing divided by ax plus e minus x divided by 2. 2 cancel with 2, you have e to the x minus e minus x divided by e x plus e to minus x. Okay, that's definition. Okay, now take derivative of sin x will be equal derivative of sin of x equal this, so derivative will be equal derivative of this, be derivative of this one equal what? Derivative ax equal ax, derivative of e minus x will be equal, take derivative of minus, okay, let's rewrite this. And then derivative of the second term will be minus x, be minus 1 with minus sign become plus e minus x over 2. Okay. And look at that, a to the x plus e minus x divided by 2 will be equal cos of x. Okay, so derivative of sin x will be derivative of cos of x, and similarly take derivative by definition. You have the derivative of cos x equal sin x, and derivative of with an x times x will be equal secant with an x right here, okay, square of x. Okay, well, this is probably not important, but you will have like, just remember this formula, then you will have some problem in your test. Okay, sin of x equal e to the x minus e to minus x divided by 2, cos of x equal e of x plus e minus x divided by 2. Okay, and tangent of x equals sin of x divided by cos of x. So take this 2 divide, you have that answer. And derivative of sin of x will equal cos of x, and derivative of cos of x equals sin of x, and derivative of x equals secant x of x. Okay, it's almost similar to trigonometric function, but it's a little different. Okay. Okay, now we study implicit and explicit. function. Okay, suppose you have like sy plus y square divided by 2. This function, you don't know which one variable. They have two variables. You don't know which one depend on this one. Have two, don't know. Which one depend on the other. Okay, so if you want to write the derivative of dy over dx. Okay, so here just the derivative of the whole thing, x squared plus y squared, and the derivative of okay, on the left hand side, the derivative of dy over dx respect to x, and here you have x squared, so x is variable, so will be equal to x. Okay, and the second term, so the derivative of y squared, so we'll lot with y squared, since y is not variable, so you apply un, so y is not, you take derivative as respect to x, not with y, so you apply y as the function, so will be equal to y and tie with dy over dx. Okay, so not on the right hand side, derivative of 2 equals 0. Okay, so now if we cancel 2 with 2, okay, so x plus y dy over dx equals 0. If you move x to the other side, you have minus x divided by y equal dy over dx. So here you find the derivative of this function using implicit. This thing called implicit. Differentiation. Okay, so that's when you the function equation not extract one by the other, but they are related. Okay, so explicit function. So that means explicit right here. So explicit, you have to solve one function to the other by the other. Suppose this one. So x squared plus y, so then y squared will be equal to minus x squared. Okay, and y will be equal square root of 2 minus x squared. Okay, with x inside of minus square root of 2 and square root of 2. Okay, so now you have equation right here, y equals square root of 2 minus square. Expect y in terms of x. Okay, so when you take differentiation or take the derivative, then you have this one called explicit. Okay, so take dy over there and take the derivative of this. Okay, that can be 2 minus x squared to 1/2 the derivative, right? Will be equal 1/2 2 minus x squared minus 1/2. 1/2 minus 1 minus 1/2, and then you then you flip it over, okay? So this one will be equal 1 over 2 square root 2 minus x squared, okay? Square root 2 minus x squared equal y. Oh, this one, okay, you need to take the derivative of this, so minus 2x. Okay, you need to take minus 1/2 down there, and then take the derivative of this, you have like 2 minus 2x. Okay. And you have to take the derivative of 2 minus 2x squared. Will be 2 minus 2x. And 1/2 switch around, then 2 cancel with 2. And you have no, the derivative of this equal minus 2x. Okay, so 2 cancel with 2, and the top will be equal minus x divided by this square root 2 minus x squared. Minus 2x squared minus 2 square root of 2 minus x squared equal y. Substitute y in here, get minus x over y. Okay, so if you take differentiation, you can use either implicit this way, okay, and or you can use explicit this way, okay. One more example. Okay, take derivative using implicit and explicit. Of y equal x times y. Okay, first one, implicit. From here, you take directly with the dy. Okay, 1 equal x plus y, okay? Okay, take the derivative of 1, d over dx. 1 equal 0. And the derivative of x times y, okay? Will be equal to the derivative of the first one and the second one. Okay, the first one is 1 times with y. Y stays still. And that's the derivative of the second one. That means the derivative of dx dy over dx of dy is equal to dy divided by dx and multiply with x. Okay. So if you move y to the other side, so minus y will be equal dy over dx by x. So divide both sides by x, we have dy over dx will be equal minus y over x. Okay, this one implicit. So let's show it explicit. Okay, you solve for y. Okay, from 1 equal sy, then imply y equal 1 over x. Okay, then you take the derivative of y, dy over dx to dy over dx will be equal this 1 over x, okay, 1 over x. Not derivative dy over dx equal minus y over x, but y equal from here, y equal 1 over x. So if you substitute here, you will have minus 1 over x squared. Okay, so here if you take dy over dx, so on the right hand side, x minus 1 derivative will be minus x minus square. Okay, x minus square, bring it down, get minus 1 over x square. So when you use implicit or explicit to take derivative, you get the same answer. But when you get to higher math, you use implicit. Must be easier than explicit, because sometimes it's very hard to show y by x in terms of x. It's very hard. In this case, we have very simple function equation, so it's easy to show y by x. But in many cases, it's very hard to show this. So you better take the derivative of both sides. Okay, and then just solve for dy over dx. Okay, so our lesson today is stop today. Okay, stop right here. So I see you next time. Okay.